Now, when you were young, I'm sure you must have gone to the park to enjoy the swing over there. Now, what do you think happens to a swing when you simply push it and let it swing for a period of time? Over here, the boy pushes the swing and lets it swing for a while. Now it moves to and fro from one end to the other, and after a while it comes to a stop. But why is this happening? Because initially he applied a force and the swing underwent oscillatory movement. But after a while, why did this oscillation stop? Why is it that the swing came to a halt after a certain period of time? Let us find out. So firstly, we consider a very simple fact. That simple fact is that the body is surrounded by air. Or in other words, the oscillating body in this case, which is the swing, is surrounded by air. Now when there is air present, there are air molecules all around, and these molecules exert a certain opposing force on the swing when it is swinging or oscillating. So when this particular body, the swing, is surrounded by air and is swinging in air, there is air friction present. So the vibrating body or the oscillating body experiences some sort of an opposing force in the form of air friction. Now oscillation is also a kind of vibration because there is to and fro movement about the mean or the central position. So due to this opposing force that is present in the form of air friction, the swing has to do work against this opposing force. So the vibrating body, in this case the swing, has to do some amount of work against this opposing force. Now what have we studied about work? That in order to do a certain amount of work, an equivalent amount of energy is required. Thus, to do this particular work, energy of an equivalent amount is needed. So where is this energy coming from? This energy is coming from the vibrating body that is moving to and fro about the central position. So we can say that the vibrating body is using its energy to do work against the opposing force. So the swing is working continuously against air friction, which is the opposing force. So as a result, what happens? The swing will lose its energy because there is no continuous supply of energy to the swing. Thus, the swing loses energy. And it is due to this reason that it gradually comes to a halt. Or in other words, its amplitude decreases gradually. So over here, when we consider the swing swinging from a fixed support on either end, it went on swinging for a certain amount of time, but this to and fro motion became less and less vigorous. It continued becoming less vigorous until a certain time where it stopped. So the displacement of the swing at its extreme position from the mean position started decreasing. So what can we say? We can say that the amplitude decreases and it gradually comes to a halt. Such kind of vibrations or such kind of oscillations are known as damped vibrations. Now what are damped vibrations? The periodic vibration of a body of decreasing amplitude is known as damped vibration. So in the case of the swing, where the amplitude of the swing was decreasing continuously, such kind of a vibration is known as damped vibration, and the phenomenon is also known as damping. So we can say that it was due to air that damping of the swing occurred. So it was because of air or air friction that damping of the swing's motion took place. Now let us consider another scenario where a boy is helping his friend to swing on this particular swing. Now in order to help his friend, the boy is applying a periodic force on the swing. That is, he initially applies a force and the swing moves forward. When it comes backward again, he again applies a force. So over here you see that the boy is applying a periodic force after certain intervals of time. He is going on applying the force, and as you can see, the amplitude of the swing, that is the to and fro motion of the swing, is not stopping. Instead, it is going on continuing for as long as the boy is applying the force. Now this kind of vibration is known as forced vibration. So in forced vibration, a certain phenomenon occurs. What is that phenomenon? In forced vibration, the vibrating body, in this case the swing, gradually acquires the frequency of the applied force. So let us take an example to prove this. Firstly, we define forced vibration. Forced vibration is when a body oscillates or vibrates under the influence of an external periodic force. And under such circumstances, the body executes forced vibrations. So there are again two things to remember over here. The body has to be oscillating or vibrating, and the force under which it is vibrating or oscillating has to be an external periodic force. So now let us see how in forced vibrations, the vibrating or the oscillating body gradually acquires the frequency of the external periodic force. So over here you will notice that in the beginning, the external periodic force of the boy is not in sync with the swing. But gradually, the boy is applying a periodic force that comes in sync with the swing. As you can see now, as soon as the swing is moving back, the boy is in sync and he is applying the force exactly at that instant. Now imagine a world where you do not have to go on pushing the swing. Imagine a world where there is no air friction and merely on pushing the swing, it continues to oscillate or it continues to vibrate. And as you can see, this vibration is going on forever. And the boy who is standing here applied a force just once and the swing is not stopping. So under this circumstance, unless and until the boy wants the swing to stop, the swing will continue swinging forever, like literally forever. So what is this kind of a vibration known as? This kind of a vibration is known as free vibration. Or in other words, if a body is vibrating without the help of any external periodic force, it is said to be executing free vibrations. Now the concept of free vibrations is largely theoretical because it is not possible to completely negate the effect of air friction. So in other words, there will always be some kind of damping which is present on the oscillating body. And due to this, the vibrations will decrease over a period of time. So such vibrations which take place without the help of any external periodic force, known as free vibrations. Free vibrations are also known by another term, natural vibration. So when I make a body oscillate by applying a force on it, it executes free vibrations till the point damping comes into play and damps the vibrations and makes it stop. So if there was no damping, then the vibration would go on forever. Or in other words, the body would go on executing free vibrations forever. So relating to natural vibration or free vibration, there are certain terms to be defined. This first term we define is natural frequency. Now what happens in natural frequency? What is natural frequency? The number of vibrations executed by a body vibrating freely in 1 second is known as natural frequency. That is when a force is applied on any body and made to vibrate. The number of cycles of oscillations that the body will complete in 1 second is known as its natural frequency. Similarly, we define natural time period. Now, what is natural time period? Natural time period of a body is time period of a body executing natural vibrations. So a body which is executing natural or free vibrations will have a natural frequency, as we discussed, as well as a natural time period. So what is the natural time period? Natural time period is how much time a body takes in order to complete one cycle. So let us say the body completes one cycle in 5 seconds. So in that case, the natural time period of the body would be 5 seconds, because during its natural vibrations, it completes one cycle in 5 seconds. Now every body vibrates with a constant natural frequency, and this constant natural frequency is a characteristic of every body or every particular substance in the universe. A natural frequency is possessed by everybody, even by you. So in free vibrations, what exactly takes place? There is no opposing force which is present, because we have completely negated or removed any sort of damping. So since there is no opposing force, what do you think will happen? The body which is vibrating will not have to do work against any opposing force. As a result, energy of the body remains constant, because this energy is not being used up to do work against the opposing force. Why? Because there is no opposing force. And because the energy of the body remains constant, the amplitude of vibrations remains the same over time. And it is due to this that once the body is set into free vibrations, if there is no opposing force, the body will continue vibrating forever. And as you can obviously see, the entire concept is quite theoretical, because it is impossible to obtain a situation where there is no opposing force. So now we try and plot the free vibrations of a body on a graph. So on this graph, we have taken the displacement of the body from its central position on the y-axis and the time through which the body is vibrating on the x-axis. Now in free vibrations, the frequency remains the same throughout. As you can see, this black line, the central black line, indicates the mean position or the central position. That is the position from where the vibration starts. So let us say at this point, the body is set into vibration and it is moved by applying a force. So immediately the body will start vibrating and start moving in the forward direction. Now this forward direction is taken on the positive side of the y-axis. Conventionally it is taken so. So this body continues moving until a certain point in the forward direction, and it goes and stops at a particular point. From this point, the body will have a tendency to move back to its mean position. So it starts moving backwards. Now this particular point where the body had gone and stopped is the maximum displacement of the body in the forward direction. So this is the extreme position. And this gives us the amplitude when measured from the mean position. Now coming back to the motion, I mentioned that once it reaches this position, the body will have a tendency to come back to its mean position. So it starts moving back and reaches the mean position. But due to its inertia of motion, because it is executing free vibrations and there is no opposing force, it continues moving backwards and it moves till a certain point in the backward direction. Now conventionally this backward direction is taken on the negative side of the y-axis. So this point where the body goes and stops in the backward direction is again the extreme position in the backward direction or the maximum displacement. So this position from the mean position will also give us the amplitude in the backward direction, which will be the same as the amplitude in the forward direction. And again this process is repeated, because even at this point the body will have a tendency to return to its mean position. So again it continues moving forward in the mean towards the mean position and it reaches the mean position. But at the mean position, due to inertia of motion, it does not stop. It continues moving in the forward direction, reaches a particular point and then stops. And this process is repeated over a period of time, and we get a graph, as you can see, has been picturized on the screen. Now, what do you think will happen in case of damped vibration? Now, in case of damped vibration, if you recall, I mentioned that there is an opposing force present. So again, I consider displacement on the y-axis and time through which the vibration is taking place on the x-axis. So what happens in this case? Let us say the body is set into vibrations by applying a force. So the body moves in the forward direction to a certain point and then stops. Conventionally, this forward direction is plotted on the positive side of the y-axis. So after it comes to a halt at a point in the forward direction, it has a tendency to move backwards towards the mean position. Now again it starts moving back and reaches the mean position. But due to its inertia of motion, it continues moving backwards and it moves in the backward direction. Conventionally, this backward direction is plotted on the negative side of the y-axis. Now once it starts moving back, it again comes to a certain point and stops. Again over here, it will have a tendency to return to its mean position. So it starts moving in the forward direction again and reaches the mean position. Again, like I mentioned previously, it does not stop over there. Instead, it moves in the forward direction up to a certain point. Now this is where damped vibration differs from free vibrations. You will be interested to learn that in this case, that is the second cycle, the body does not move to the same point in the forward direction. Instead, if it had moved to a certain distance x, in the second cycle, it will move a distance lesser than x. Why? Because of the damping of air, that is due to air friction. The body is doing work against air friction, so it's losing energy, and as a result, the amplitude is decreasing. So the body moves to a particular distance that is less than the previous one. And again, the entire process is repeated for this cycle. In the following cycle again, when the body moves forward from the mean position, its displacement will be even lesser than in the previous case. So in this way it continues till a point comes when the displacement of the body from its mean position becomes 0. And that is when the body has come to a perfect stop or halt due to damping. Now again in this case, in case of damped vibrations, it is important to remember that frequency remains the same. It is only the displacement from the mean position that keeps on changing. No difference takes place in case of frequency. That is the number of cycles in 1 second. The frequency remains the same. So let us take a quick recap by visiting the differences in between free and damped vibrations. So firstly, the first difference between free vibrations and damped vibrations is that for free vibrations, the amplitude remains constant. Whereas for damped vibrations, as we studied, the amplitude goes on decreasing due to the opposing force. Secondly, in free vibrations, the vibrations will go on continuing forever. So if I apply a force and leave the freely vibrating body, in the absence of an opposing force, the vibrations continue forever. Unlike what happens in damped vibrations. There, the vibrations ultimately cease because there is an opposing force which reduces the amplitude gradually. Thirdly, there is no opposing force which is present in the case of free vibration, and it is due to this that the vibration remains constant and the vibrations continue forever. But in damped vibrations, there is a frictional or a damping force which is present. In this case, we considered the damping force due to air friction. So it is due to this opposing force that the amplitude decreases and the vibrations ultimately cease. Lastly, in free vibrations, there is no loss of energy. The energy remains constant for the vibrating body, and that is why the vibrations go on forever. But In damped vibrations, what happens is there is a loss of energy because the vibrating body is using up its own energy in order to do work against the opposing frictional or damping forces. So since it is using this energy against these forces to do work, it is losing energy. So these are the basic differences in between free and damped vibrations.